Hey everyone, it's Miss Lloyd again, coming to you with double angle and half angle formulas for trigonometric functions. First off, we're looking at the double angle formulas and identities for sine and cosine. Sine is pretty simple. We have sine times, or sine of 2 times our angle, whatever that is. In this case, we're using alpha. Is equal to 2 times sine of that angle times the cosine of that same angle. For cosine, it's a little bit different. It depends on either what you're given or what you're trying to find. So if you have cosine and sine, you could use this first one in orange, cosine squared of alpha minus sine squared of alpha. Maybe you only have sine, so you can plug it into this 1 minus 2 times sine squared of alpha. Maybe you're only given cosine, and you can use this last one in blue, 2 times cosine squared of your angle. Oh, that should be alpha. It definitely does not look like an alpha here. No, it does a little bit. And then minus 1. So it depends on what you're given, what you're going to use, what you would want to use. I like to take the easy way out and use whatever they've given me in order to find this out. So cosine, we have a little bit more options. When it comes to the half angle identities, cosine is very important for these because no matter which one you're looking at, sine or cosine, you're going to be using cosine for that half angle formula. So for this first one, they're asking if sine of our angle is equal to 4 over 5 and is in the second quadrant, we need to find the sine of double that angle. So I want to recall the formula for sine of 2 times our alpha. That is equal to 2 times sine of the alpha times cosine of the alpha. So that angle. So they've already given me the sine of the alpha is 45. Or sorry, not 45, 4 over 5. So that means I need to figure out what my cosine is. So this is where they give me a little bit extra information with that second quadrant, so we can figure out what the cosine might be. So when we're in the second quadrant over here, I know when they give me my sine, they give me my y over my radius or my hypotenuse, however you want to look at it, so the opposite over the hypotenuse, which means I know this up and down here, my vertical, whenever I create my my triangle is going to be a positive 4, and my hypotenuse for this reference triangle is going to be 5. So what I need to figure out is my x value so that I can use my cosine, because cosine is the x value over the r. And I know just by looking at this that this is a Pythagorean triple, so the 3, 4, 5, which means this is going to be 3, but because we're in the second quadrant, this is going to end up being a negative 3. We've gone left on the x-axis, so that means my 3 is negative, which means my cosine of my alpha is going to be negative 3 over the radius of 5. Now that I have all of that in, I can plug it in. So this is equal to 2 times 4 over 5, which was sine of alpha, times my cosine of alpha, which we found was negative 3 over 5. Multiplying all of that together, we end up with negative 24 over 25. So you could think this is 2 over 1. So 2 times the 4 times the negative 3 will end up getting us negative 24. And the 5 times the 5 will give us a negative 25. And we're done. Not too crazy. For my next example, they want us to find the exact values of cosine of 5 pi over 8. So this is where, if my students don't remember the radians in the unit circle, this is where they will get stuck. So here we have to be able to recognize that anything that I know about 5 pi, I don't know 5 pi over 8, but I do know 5 pi over 4. And in order to get from 5 pi over 8 to 5 pi over 4, that means I would have had to multiply by a half. So this means that I'm looking at the half angle identity for my cosine. So we're looking at cosine and our alpha, or theta, in this case, we were using theta before, would be 5 pi over 4. And then this would be divided by 2 in order to get that 5 pi over 8. So this will end up being the same thing. So I can use my half angle identity in order to figure out what cosine of 5 pi over 4 is, and then that whole identity will tell me the 5 pi over 8. So plugging this into the identity, this is the plus minus 1. We'll have 1 plus my cosine of 5 pi over 4 divided by 2. Simplifying this, I can change my cosine of 5 pi over 4. I know that's my pi over 4 reference. Pi over 4, cosine of pi over 4 is square root 2 over 2. Because it's 5 pi over 4, I know that's the one that's in the third quadrant. It's a bit over a full pi, so that's in the third quadrant, where cosine is going to be negative. So this is now negative square root 2 over 2. And then all over 2. So from here, a lot of this is just really gross, so I want to try to simplify it as much as possible, especially since technically I have a square root in the denominator, and that's not okay. We want to make sure our denominator is rationalized. So I'm going to kind of clean this up as much as I can before everything goes insane. So first, I want to separate these a little bit, so I'm going to end up with 1/2. This is going to be minus, since it's plus minus, square root 2 over 4. Since I have square root 2 over 2 over 2, that would be square root 2 over 4. If I can make the denominators the same, I would have this all over 4, which I can take the square root of. So I'm going to change this into 2 over 4 for my first fraction, minus square root 2 over 4. So I've changed this fraction into 2 over 4, so then I can combine my fractions. I would end up with 2 minus square root 2 all over 4. Now that those are separate, I can take the square root of just the bottom and bring that out to the front, which would make it a 1/2 when I take the square root. And then this is, now I just have the numerator, so it would be 2 minus square root 2. I don't have a denominator now, so I don't have to worry about, I've rationalized what I can. You could also just put this whole thing over 2 instead of multiplying by 1/2. That would end up being the same thing. But I'm just going to leave it like this. So one tiny fraction instead of a big one. My next bit, they want us to prove the following identity. And looking at this, I always tell my students you want to start with the grossest side and work your way to make it look like the not so gross side. Looking at this, it's very, very obvious that the left side is the grossest side. It has the most with it. It also has double angle situations. So I'm going to replace those with the double angle formulas. So when I'm looking at sine of 2 times our angle, I'm going to replace that with the only one that we have. So 2 times sine of my angle times cosine of my angle. And then this is going to be over 1 minus, I do have several cosine double angle formulas to choose from. Because I have this 1 out in front with it, 1 minus this whole thing, I want to use something that has a positive 1 so that the 1s will subtract and I'll get rid of them. So I'm going to be using the 1 minus 2 times sine squared alpha. And this is equal to cotangent. So that I want to keep the same the whole time. I'm just going to try to rearrange the left side. My negative, I'll distribute in on the bottom. Now I can simplify some things. So I've got my 1 minus 1 that's going to cancel out here. That way I have everything just multiplying together. Can probably start canceling some stuff out after that. Next, I have the 2 on the outside on top and bottom, so I can cancel out those 2 since everything's multiplying. Also, I technically have 2 signs on the bottom with that sine squared, so I can cancel one of those out with a sign that's multiplying on top, leaving me with just a cosine of my angle over sine of my angle, which is the same as cotangent of the angle. So my last step is just to write that those are the same there. Do you want to make sure that you show as many steps as possible so that people can see what your thought process is? and not that you're just fast forwarding to the end and you don't actually know what you're doing. Next page, we're looking at them wanting us to simplify to a trig function of a single angle. So they don't want us to have this mess. They want us to just have one trig function with one solid angle. And they don't want us to evaluate. We don't have to plug it in or anything or try to use the unit circle. They just want us to smush this down, if you will. This first one I can see is a double angle. I have 2 times sine of an angle times cosine of an angle, which means this is my sine double angle formula. So 2 times some angle. In this case, I know that some angle is going to be 17. So my alpha here, instead of that, I'm going to be plugging in 17. I'll be multiplying that with the 2. And so we're really looking at sine of 34 degrees. Again, they said we don't have to evaluate, so this is as far as I'm going to go. And that's all we gotta do. So figure out which formula it is and squish it down. This next one, I have a square root, so I know that I'm looking at the half angles because the half angles are the ones with the square roots. Those are really gross. Because I have this plus, I know that it's the cosine of the half angle. So cosine of theta over 2. If it was the minus, it would have been the sine. Because there's a plus there, I know it's the cosine. And the angle that we're using in this case is the 100. So I can replace that theta with 100 degrees and then simplify by dividing by 2. So I'm looking at cosine of 50 degrees. Again, we're not evaluating. It says do not evaluate, so this is as far as we need to go. Just smushing it down into 1. And then we're looking at my last question. So my last question, they're telling me that my angle is in between 90 and 270 degrees, which means I'm either in the second or third quadrant. And they tell me that sine of my angle is negative 4 times square root 5 all over 9. Sounds really gross. And they want us to find cosine of the double angle. So remember, with cosine of the double angle, we have 3 options. Because they give me sine of my angle, I want to use the one that only has sine in it, and then I don't have to figure out what the cosine of that is. And that's really why they give you this information here, is if you want to figure out what the cosine of the angle is, you can figure it out this way. But technically, I don't have to, because I can use the cosine double angle that just has my sine in it. So the 1 minus 2 sine squared of the angle. We could use the one again with cosine, but we'd have to draw it all out. We would have the opposite over the hypotenuse thing with my sine, and then you'd have to figure out what the adjacent side was, and it's a little bit more of a mess. This, I think, is easier. So working smarter instead of harder, if you will. So I'm going to replace my sine. Again, this is squared, so that's like sine alpha times sine alpha. So I'm basically doing the negative 4 square root 5 over 9 quantity squared whenever I'm replacing the sine squared alpha. And so I'm doing order of operations, so I want to distribute in my square to everything. I would end up with negative 4, and negative 4 would give me this positive 16. Square root would go away, leaving me with just 5, and I've got 81 on the bottom. I can distribute in my 2 now. Multiplying is helpful, so 2 times the 16 times the 5 will end up giving me 160 over 81. I'm not able to simplify that, so I'm going to change my 1 into 81 over 81 so that I can combine my fractions now that they have the same denominator. And I end up with negative 79 over 81. And this is as far as we can go. Again, I can't simplify, so it's all we gotta worry about. Ta-da! And so those who are my students, you can find your homework in the LMS. Whether you are my student or not, please like and subscribe and share this with anyone who you feel like it would benefit. If you know there's someone struggle busing with some double or half angle identities, please share this with them, especially in the times that we're going through now. We want to make sure that we spread the love.